On This Week in Enterprise Tech, this is filled with magic. We talk all about rapidly deployed networks, and SDN is in the air. Twice on the set.
Netcasts you love.
From people you trust. This is Twit.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CacheFly.com.
This is Twit. This Week in Enterprise Tech, episode 55, recorded August 19th, 2013. Prism ain't a prism. This Week in Enterprise Tech is brought to you by GoToMeeting with HD Faces by Citrix, the powerfully simple way to meet and collaborate with colleagues and clients from anywhere. You can share the same screen and see each other face-to-face with HD video conferencing, even from an iPad. Sign up for your 30-day free trial today. Visit GoToMeeting.com, click on the Try It Free button, and use promo code ENTERPRISE. And by Ting.com. Ting is a mobile phone service that makes sense. Save money with Ting, pay for what you use, doesn't require a contract, and offers unlimited devices on one pooled plan. To save $25 on your first Ting device, visit enterprise.ting.com. That's enterprise.ting.com. And by Lookout, a mobile security company trusted by over 40 million customers. Lookout specializes in stopping new cyber threats, finding lost or stolen phones, and backing up data. Protect your Android or iOS device now by visiting lookout.com/enterprise for the free download. Welcome to Twit, This Week in Enterprise Tech. It's the show dedicated to the enterprise professional, the IT pro, and the geek who just wants to know how the world is connected. I'm your host, Father Robert Balaser, the digital Jesuit, your guide to all things in the enterprise. And you know I'm not alone. I'm joined by, of course, my all-star cast panel, starting with Mr. Brian Chi, the director of the Advanced Network Computing Laboratory in Honolulu, Hawaii, the geek in paradise himself. Brian, how is your hollowed-out volcano headquarters?
All is good. In fact, give some love to the Windows Mobile guys. I just got my Nokia 925. It's so much fun. I love it.
Do you have a new toy, Brian?
Yes, I do.
Okay, well, we're going to have to ask you about that when we go back into a Windows Phone special. But before then, I do want to stop by on the other coast, Mr. Curtis Franklin from Enterprise Efficiency. Curtis, this is not your regular place. Where are you now? You are always traveling.
Sure enough, I'm on the road again. I'm at a Homewood Suites in beautiful scenic Bonita Springs, Florida, down on the southwest coast. Rain's already been through once today, but it's a beautiful day down here just a few miles from the scenic Estero Bay.
Well, my networking brothers in arms, it's always nice to see you, always nice to have you on the show. So let's get right to it. This is normally when we start with an enterprise bite, but you know what? We've got something a little different today. It's a well, actually. That's right. We get bombarded with email messages and Twitter tweets all about things that we did wrong on the show. And most of the time, I love it. I love listening to people. I love hearing feedback. I like knowing when we went wrong. But there is one person, Richard, I'm just going to call him Richard, in the chat room who was a little bit miffed that we got something wrong. Let me just read you his email. In episode 46, NSA Deep Dive, you contradicted Steve Gibson's revelation about Prism by saying about taps, if you open it up, it really is just fiber. There are no complicated optics in there. They just have a really good way of scraping away some of the cladding and getting enough, just enough of the light to allow the signal to continue to propagate while getting their tap. As an engineer of 30 years, I have to say that you couldn't be more wrong. There is no way to split the light simply by scraping away the outer cladding of the fiber. More so, you would never be able to maintain signal integrity without a set of precision mirrors to redirect some of the light energy into another strand of fiber. Every tap that serves 1 gig or 10 gig enterprise networks absolutely uses prisms to accomplish this beam splitting. I still love your show, but you shouldn't mislead people into thinking that optic tapping devices are magical boxes with only a few pieces of fiber inside. Well, Richard, you know what? You're right. We don't like misleading people. We don't like giving them erroneous information, and we do like giving them the truth about tapping. But in this instance, I think maybe we need to err on the side of magic. If Jason will go over to our product cam here, I've actually got a professional grade Net Optics 1 gig and 10 gig flex tap. So these are the taps we actually use at Interop. They're fantastic. They allow us to put a bunch of these into a chassis and then take a single feed and, well, just take the tap that we need. So we've got in and out, and then we've got the tap side. Now, if you actually look inside one of these bad boys, this is what you see. That's right. No fancy mirrors, no prisms, no really nothing. There's no beam splitters. There's no blocks of glass. There's no complicated apparatus. In fact, all you have is the fiber that goes from the input to the output. So that's the tap, the pass-through. And then this green one here is actually just taken off of, I'm not sure if Jason can get any tighter on that. You can see how you have one fiber in on this side, 2 fibers out on that side. So they've just scraped away enough of the cladding and they've encased it in this epoxy to make sure that it stays in place. Now, this is a 70-30 tap, which means that 70% of the light will pass through and continue onto the device that it was intended to pass onto, and 30% of the light comes out and allows you to actually see what's going on within the tap. Now, Cheever, let me ask you about this first. We both worked with a lot of technology like this. Richard used to be right, yes? I mean, in the old days of networking, you actually did require a prism. You required some fancy equipment inside one of these boxes in order to get the tap.
Actually, yeah. In the old days, let's call it when NASA was using the star switches, it was a set of semiconductor mirrors to flip the light around and switch it and tap it and so forth. The trick is we're using some physics that when you're bouncing a whole bunch of light around inside a tube of different, it's kind of like, when you have a mirrored tube and you're bouncing it around. If you scrape away a little bit of that and the light's bouncing around, a little bit of light is going to leak out. You can actually make your own. Single mode taps are pretty easy to make. You can actually sit there with a dissecting microscope and a good sharp razor blade, and you can very gently scrape away the cladding. Keep in mind it's 62.5 by 125 or 50 by 125. So that means you got to scrape away half the diameter. And the second you start getting into the core, just barely nicking the core, you're going to see a blast of light. The easiest way to demonstrate this is when you have something like a fiber finder, a laser with a collimating lens on it so that it spreads the beam. If you have a break in the fiber, it will actually fan out and even shining through the PVC coating, you're actually going to see this big band of light right at the break.
Right, and actually that's one of the principles about light traveling through fiber that we use to find breaks. We have a laser that we attach to the barrel of the interface with the fiber strand, and we just look for the bright red light shining out. That tells us, okay, that's where our break is. That's where it's maybe bent too much, because you don't have to break the fiber in order to get that light out. If you bend it enough, you'll actually see it on the cladding. Now, people in the chat room are wondering if I let the blue smoke out of this thing. There is no smoke because there's no electronics. And believe it or not, even though I've cracked this thing open, and yes, this is a very expensive piece from NetOptics. So Aaron from NetOptics, if you're in the chat room, I'm really, really sorry, but it was already broken, so it wasn't me. There's no electronics, therefore no blue smoke. Cheever, anything else about taps? I mean, is this the last word? I don't want this to be a smackdown. I think Richard actually brought up a really good point, and that is we used to require expensive beam splitters and mirrors, but just recently we found an easier way to do it. This is as simple as it gets for tapping, right? I mean, there's no magic, there's no unicorn blood, there's no super secret sauce. It's just fiber that we've bent to take out some of the light.
Actually, in the case of that single mode, it's actually not even that. The people that actually manufacture these things have some really, really sexy fusion splicers. And what they're doing is they're offsetting the core. And so that's how we're getting the 70-30. And that's the reason why taps like the 90-10 are so freaking expensive, because they're harder to make.
Yeah. There's a question from Job in the chat room. He wants to know if this would work for big pipes. Remember, this is a 1 gig tap. This is a 10 gig tap. So yes, it works for really big pipes. In fact, if I were to take this out of the box, it looks exactly the same. Light is light is light. Now, I do want to move on, but before we do that, I will say that if you happen to be an interop, you got to knock on the windows, either New York or Las Vegas. You're going to find me. You're going to find Chibert. And I'll actually open one of these up for you if you're still not convinced that this is an optical tap. Let's go on to the next Enterprise Bite, and that is, does the cloud still make sense for business? This is an article out of Wired that focuses on several startups here in San Francisco and around the Silicon Valley that have moved their services recently from the cloud, most notably from Amazon Web Service, back into a private cloud or into a private server closet. They're stating that while the cloud may be good for startups because it allows for quick expandability, rapid expansion, it's not so great once you've established yourself. It gets too expensive. They use the example of Eric Frankiel's San Francisco-based MemSQL, which moved their operations from AWS to their own private servers because they figured out that it would cost them about $324,000 a year for AWS, whereas they could buy the same number of servers for about $120,000. Now, Chibert, let me throw this to you first. We are big on the cloud. I love the cloud. I love the ability to spin something up really quickly, to dynamically allocate resources. But it seems that this is a story that's being told more and more times. Startups that realize the cloud's not as cheap as they thought it was. Is this something we'll continue to see, or is this just an adjustment of the economies of scale?
I think these folks have forgotten a few variables in the equation, like the HR cost to maintain all this stuff. The fact that if you build your own data center, it's only in one place. The nice thing about a cloud, say Amazon Web Services, it's minimum in 2 places. And even if you say, I want it only in the United States, it means it's going to be on both the East Coast and West Coast. And if you're using something like that or Google or what have you, you also have global load balancing, which makes a pretty big difference. So maybe they bought it for $120K, but if you start comparing apples to apples, maybe it wasn't such a great deal after all. Clouds do make a lot of sense. And with more and more people getting into the cloud, the cost of clouds are dropping rapidly. And the fact that Microsoft Server 2012 R2 has the ability to run Azure services for Windows Server 2012 R2 and be able to automate the process of moving up into the Azure cloud to handle load and then shrinking back when you don't need it anymore. That's a pretty powerful feature.
Right. Curtis, over to you. Tradesy, Mixpanel, Uber, Zynga, all companies located here in San Francisco who have moved their operations from the cloud, from Amazon Web Services, from any other cloud-based, dynamically allocated resource farm into their own closets. Do you see this on the enterprise level? I mean, we've always been wondering whether or not enterprise is going to trust the cloud enough, but are they now looking at ROI and saying, look, there's no reason for us to expose ourselves to the public cloud. There's no reason for us to expose ourselves even to a private or semi-public cloud. It's better if we just own all our own gear.
I think it probably has to do more with the accounting that they're doing in the particular part of the life cycle. Because remember that one of the big things that happens when you go from your own closet to the cloud is that you take expenses out of the capital part of the ledger and go on to the operating part of the ledger. Capital expenses typically have to be amortized out over at least 5 years. In other words, if you spend $124,000, you can't take a $124,000 charge against your income this year. You have to spread that out over 5 years. On the other hand, the $324,000 you spend on your lease payments to a cloud provider all comes straight out of the taxes. It's accounting that you can pull off the income this year. So it depends to some extent on what you're trying to maximize. Do you want to minimize your expenses to make your profitability look good? Let's say if you're planning to go public, if you're going to do something like that, then bringing stuff in-house, spending some money now but not being able to amortize it for a while may make sense. On the other hand, if you're either staying private or you're already public and trying to minimize capital expenses, then that's where going to the cloud makes a ton of sense. So accounting rather than technology plays a huge role. The other thing you have to remember is that according to Gartner and pretty much everyone else, comparing purchase price against the total cost of the cloud is not at all an apples-to-apples comparison. When you look at total cost of ownership, the basic purchase price is a fairly small component. Like Chibert said, you start rolling in all of the HR, all of the training, all of the utilities, everything else, and the accounting starts looking much, much different. I have a feeling that what we're seeing is that companies are entering specific phases of their lifetime and needing to shift expenses from one part of the ledger to another. Once they go a little bit more in the direction of maturity, my suspicion is we'll see many of these people very quietly heading back to the cloud.
I love that. I love that analysis because it includes not just the technology side, not just the privacy side, which we're going to talk about in a bit, but also that economic side that I think engineers sometimes forget. As an executive looking at a cloud option, you're right. Being able to structure how you take these charges does become really, really attractive. Now, I want to come back into this, but first, a bit of breaking news. Right before this show started, we started getting reports that Amazon was down in different parts of the country. We had someone in Arizona, someone in Florida, someone here in California. And so if Jason has that queued up, we could, no, it doesn't. But instead, what we're going to do is we're going to talk about the reliability of the cloud. These companies were all running off of AWS, Amazon Web Services. One of the things that people used to say all the time was, well, what happens if those servers go down? What happens if that service is no longer available? Now, I've also been told that Amazon Web Services haven't directly been affected, neither has Amazon storage offerings. However, the fact that their own private servers could go down, either getting DDoS or having some sort of technical difficulty, does highlight another problem that enterprises are going to have to grapple with, and that is if we are running our operations on someone else's servers, what happens when things break? Chibert, I know this is an old fear. I know we've addressed it before, but what's your take on this? I mean, is this just part of the price of doing business, or do you have to have a contingency? Do you have to have a private server farm along with your public web operations?
You know, this is one of those questions where it's hard. It's like asking what's the best car. It all depends on how you do business and things like that. Microsoft is actually making it a lot easier to flip back and forth between public and private clouds, between your private data center and the cloud infrastructure. The reality is no one answer fits all. It might make sense for some, it might not make sense for others. I think you need to go and take a good hard look at and realize this is the first time that I can remember Amazon ever going down. And it's going to be really interesting to see what it took to take down this giant. And maybe we all need to take a lesson from that.
Curtis, odd question to you. At this point, with web services as mature as they are, it almost seems as if it would be better that this was a hacker attack, right? This was a directed DDoS attack at Amazon servers than some sort of internal misconfiguration. Remember when that happened to Netflix, or when that happened to Amazon storage offering? That scares people more, that there could be some little glitch that takes down the entire system, than it being attacked by a bunch of hackers.
Oh, absolutely. I mean, in the same way that we love the idea of conspiracy theories when bad things happen on an international level, because we can readily believe in the idea that there's this vast evil cabal that can put together the resources to take down someone of importance or something of importance. But the idea of just the random loner having a huge impact on international affairs scares us, because there's really very little that can be done to protect against the random loner. In the same way, we found out last week when the New York Times went down for several hours. The reports that we got was that it was a firewall misconfiguration that took down their servers. It didn't allow anyone to access their servers for several hours. The idea that someone somewhere could hit an off switch with a broom handle and take down Amazon is scary, because it's really tough to protect against all of the broom handles that enter every data center that Amazon's involved with. It's much easier to be comforted by the idea that there are vast armies of very intelligent but somehow tragically misguided people out there who can in fact take down a service. I think it's interesting, while we were talking, I went over, tried Amazon again. They've now gotten to the point where they do have an error page up, which indicates that they know they've got a problem, and they're at least being able to redirect their traffic around the black hole. I can still hardly wait to find out what's actually going on with Amazon today.
I love it. Now, we do need to move on. I want to touch a bit more on privacy, because a few people have mentioned, along with the taps, whether or not we're going to be doing any updates on spyorific things. Yeah, that's a word. I just made that up. We've got a story here from the Google Cloud Platform. That's right, the Google blog itself, about how they're going to encrypt your cloud data. It's going to happen in 2 phases. From now on, anything new going in, that includes your drive, that includes your email, that includes your pictures, any data that you put on the Google Cloud Storage servers is going to be encrypted. Now, encryption on older data will be available in a few months, and that's because they actually have to go back and encrypt things that are already there. But the process will be that your metadata and your data will be encrypted using an AES 128 key, and then each of those keys is in turn going to be encrypted by a master key. Google will hold on to the master keys, but they're assuming that this leads you to, well, trust them more, trust your data more. Chibert, let me ask you this. It sounds great that Google is encrypting, but does it really mean anything if they actually hold the keys?
Well, yes, it does and it doesn't. You know, just because someone has a key doesn't mean they're actually going to use it. It's kind of like what GSA built for the State Department. GSA actually had the master keys, but it was such a royal pain to get to them that we had to have like 6 different managers and a director to sign off in order to get to it. So we had to justify the crap on when we wanted to get to a master key. I'm pretty sure Google's going to be doing the same thing, or at least I hope Google's going to be doing the same thing. And for an external agency, say like the NSA, to get to it, I'm hoping it takes at least a court order.
Right. Curtis, over to you. Google themselves, in sort of like a little sort of under the breath type talking, said, well, if you'd like to manage your own keys, that's still possible. You just encrypt your data before it goes up into our servers. It's almost as if they really wanted to tip people off to say, look, we're encrypting, but if we're compelled to do so, we will still have to turn over these keys. So if you're really serious about your security, you should encrypt before it gets encrypted by our encryption. Does that sound about right to you? I mean, I know we're all fans of encrypt, but this shouldn't change your strategy, right? You shouldn't now say, oh, well, if Google's going to do it, I don't have to worry about it.
That's exactly right. I think what we have now is Google saying, you know, for those of you who don't really care about privacy, we're going to put some nice window dressing on it. We can try to at least slow down the random hackers, but believe me, if the government comes in, as Brian said, with a court order, we're going to give them all your data. If you want something to be protected, encrypt it yourself. Use the strongest mechanism you can. Keep the keys tightly under your control, and do that before it ever leaves your premises. That's been the rule for a long time, and nothing that Google's doing is changing the basic rule of law when it comes to encryption.
Trust no one, especially me. Now, when we come back, we're going to be talking all about RDN, Rapid Deployment Networks. It's a very specific subset of networking that involves a lot of geekery, a little bit of hackery, and definitely a lot of interesting equipment. But before that, I do want to take some time to talk about the first sponsor of the Twilight Riot, and of course, that's our old friends Citrix and GoToMeeting. Now, it's summer. We know that the kids are out of school, maybe starting to go back in, but there are still places to be. We want to suck up. We want to savor the last bit of fun from this warm weather. But when you're out and about, when you're enjoying yourself, you can't be at work. It's hard to be in 2 places at once. That is, unless, of course, you use GoToMeeting with HD Faces. You can meet and collaborate anywhere and stay in touch with your team, with your contacts, with your collaborators, with your customers. That's the promise of GoToMeeting. Now, with GoToMeeting, it takes just a click to share your screen and work on documents in real time. You can turn on your webcam to make your online meeting an HD video conference and see each other face to face. It really is like meeting in person. You can see that subtle frown or that smile. You could see the smirk. You could see when someone really does get it or needs a bit more convincing. You can easily launch or join a meeting from wherever you are, whenever you need to, using your computer, smartphone, or tablet. You can even present from your iPad. How's that for flexibility? Now, you may have noticed that I am particularly enthusiastic about GoToMeeting. It's not just because they've supported the Twilight Riot from the beginning. It's because I use it on an almost daily basis for my work and for my podcasting. You see, I'm not just a spokesman for GoToMeeting, I'm a customer. My work has me meeting with literally hundreds of coworkers and colleagues each month. Now, I used to jump in a plane every time I had a meeting because that was what you did. That was the accepted way of doing business, getting face-to-face time. I switched to GoToMeeting with HD Faces, and I tell you, I haven't looked back. Not only did it cut my travel time per month in half, but it allowed me to have more interaction with the people I needed to collaborate with the most. It saved my organization money, saved me time, and saved my sanity. I love GoToMeeting. It's easy to use, and with HD Faces, it really is just like meeting in person. So here's what I want you to do. I want you to enjoy GoToMeeting as much as I have. I want you to try it free for 30 days. I want you to visit GoToMeeting.com, click the Try It Free button, and use the promo code ENTERPRISE. Remember, use the promo code ENTERPRISE. GoToMeeting, meeting is believing, and we thank Citrix for their support of This Week in Enterprise Tech. Now let's get to it. We're talking about RDN, Rapid Deployment Networks. So I thought we should bring in an expert, someone who has built many RDNs, maybe something in the data center. I'm Father Robert Balacer, the Digital Jesuit, host of Twilight, This Week in Enterprise Tech on the TWIT TV network. We're here at the Interop Hot Stage, one of the largest temporary networks in the world, for another edition of the Data Closet. This time I'm sitting next to lead engineer, lead architect of the Interop network, Mr. Glenn Evans. Glenn, thank you very much for talking to us again.
Thanks, Padre. Good to be here.
We are here to drop the knowledge about RDN. That's right, Rapid Deployment Networks. It's kind of a buzzword in the geek culture, but what exactly does that mean? I mean, of course, it means a fast deployment of a network, but why is that separated from typical network deployment?
I think probably looking at the definition, rapid deployment networks, it's something that provides the functionality that event producers and attendees require in a simple and quick to deploy format.
I got it. So it's not just the idea of take a regular network and put it out really quickly and then take it up really quickly. It's actually a different way of thinking about how you deploy what services you need.
Yeah, very much so. I think our basic premise is keep it simple. The traditional way of building networks is to put as much gear in there as you can and have fun with it and try and make it all work together, where our model is really what can we take out and still provide the functionality that everybody requires.
This idea of building a network, a fully featured network, basically a telco, building it here in California, tearing it apart, putting it up into 1, 2, 3 trucks, moving it over to its location either in Las Vegas or New York, reassembling it, monitoring it, managing it, tearing it back down, and then trucking it away. That's become easier over the last couple of years, right? I mean, the promise of a rapid deployment network has become more and more possible as technology changes. What are some of those technology changes?
Well, I think to a large degree, it really depends on scale. We look at the very basic rapid deployment network would be something you would deploy after some sort of natural disaster, which perhaps uses the cell phone network or the cellular data network or whatever connectivity is available, and allows the downstream users, your clients, to connect and get access to the outside world. So and you call that the emergency service type rapid deployment network. Then we go up to something that we do where we're deploying, the event business or the event technology type business, where you're deploying networks for up to 100,000 people. but you've got a very limited time frame to install. You know, you're looking at a 4-day lead time perhaps to install these networks on an event site before it's got to go live and it has to work. And you know, you look at these days, people expect wireless to just work. They want the same experience in the event space or on the event floor that they do have at home or at their local Starbucks. And that's always a bit of a challenge.
It is amazing because we roll into these venues often with nothing. I mean, sometimes we get to use in-house fiber, but many times no. It's really, we only get to use what we bring.
Yeah.
And in essence, because it's such a short time frame, we are way more disadvantaged than someone building out a network for, say, an office building, because we don't have the time to get it right. It has to work at the beginning, otherwise our customers get upset.
Very much so, yeah. Now we obviously, you know, within our environment, we pre-stage a lot of the gear. So we've built it, we've tested it, we know it works. We build it in a modular format so that we can scale the network up and down depending on, you know, the amount of rooms that we have to wire, the amount of space we have to network. So we make it modular, we make it simple. One of the things that's helped us over the last couple of years has been a move to a, well, you know, for want of a better phrase, a cloud mentality. You know, once again, there's a lot of different definitions for the cloud, and you've got the public and private and whatever else. But for my way of thinking, it's more a methodology on how to operate things. You know, the traditional cloud sort of thing is CPU on demand, storage on demand, you know, bandwidth on demand. So if you take those sort of, you know, thought processes and apply it to the event business, you're then able to create, you know, almost networks on a demand. You know, we can scale up, we can scale down, you can build a base, you can add, you've got building blocks. It's so almost like a big Lego set.
You've got all those core services, and we put them into our colos, into you know, a private cloud, essentially.
Yeah, some of our basic services, DNS, DHCP, some of our management functionality. They can be in a private cloud or they can be in a public cloud to some degree. But when we actually come to deploy on show site, we know that's working, that's there, and all we're really focusing on is the physical connectivity.
Tell me, with all the years of experience you have creating these event networks, what would be 3 secrets, 3 hints, 3 pieces of your special sauce that you think everyone needs to keep in the back of their mind as they're designing, deploying, or tearing down an RDN?
I think probably my 3 tips would actually apply to both RDN and a standard enterprise or, you know, ISP or whatever. What really doesn't matter what sort of network it is. It's keep it simple, document it, and document the hell out of it. For want of a better phrase.
There's never too much documentation.
Yeah, you can never. Yeah, you've really got to know every bit. You know what everything's doing, and then have some good people to run it. Yeah, to a large degree, the technology is great, and the best equipment's pretty useless without the right person to drive it.
Right. Even the most expensive piece of gear is a paperweight without someone who knows how to use it.
Yes, very much so.
Glenn, thank you very much for talking to us. Thank you for sharing some of your experience, some of your knowledge.
Thank you.
You stay tuned, because we're actually going to be with this man again. We're broadcasting live from Interop at the Javits Center, the happiest place in networking, maybe?
Yeah.
We'll get back to that. I'm Father Robert Ballasare. Stay tabbed. Chibert, we have been working on rapid deployment networks for the better part of our lives. And you know, it really is a subset. I never used to think so until I actually started doing Interop, and I realized, yeah, you know, there are certain things that are different about putting a network up that you know that's going to just exist for a few days. So let me ask you, what is your secret sauce been over the years? I mean, because you've done way more Interops than I have. As you've seen these networks go up, what are the things that you change between the way that you deploy an RDN and the way that you deploy, say, your campus network?
Yeah, geez. Rapid deploy networks usually don't have enough time to document as well as I would really like to. Glenn kind of cracks the whip on us and saying, you know, document, document, document. And it's gotten to the point where we can't keep up. So from year to year, I actually have in the cloud, I store all my documentation so that I don't have to start from scratch each year. In the case of deploying, say, a campus network, I try and take a little more time. I actually try and build into the timeline documentation. Otherwise, someday someone's going to find it, the stray chunk of wire and going, where does this go? And they plug it in someplace where they think it works, and it's going to take my whole network down with, say, a router loop or something.
Right.
So the big difference is documentation, how well you do it and so forth. I actually really build the time into the schedule.
Right. Curtis, over to you. RDNs, it's not typically something that enterprise deals with a lot. When we install a network for an enterprise, we assume it's going to be around for years and years and years. I mean, we take the budget over the next 5 years, 10 years, 20 years, however long that equipment is going to depreciate. But there is a certain subset within the enterprise that does need networks that can go up and come down really, really quickly. Is this something that enterprise people plan for, or they just grab whatever they've got in the server closet and do their temporary deployment?
Well, I think there are a couple of different categories where people look at rapid deployment networks, and they're treated differently. One of them is the rapid deployment network that is part of a business continuity plan, something that might be deployed in a worst case scenario if you have to essentially bug out of your main data center, or more likely, to be honest, out of regional data centers, out of branch offices, something like that. To continue operations of these remote areas, you'll need a small, remotely, rapidly deployed network, and they will typically stage those in a warehouse ready to be drop shipped along with some talent to wherever they're needed. This actually reminds me a great deal of what goes on in the amateur radio world when we practice emergency procedures. You have things like memorandums of understanding. It's a way of getting to what Chibert was talking about, the documentation. Knowing what's going to be going on, having that recipe book that tells you exactly how not only the physical pieces are going to be deployed, but how they're going to be used and by whom at every step along the way. The other way of using a rapid deployment network, though, is for a limited subset of companies that might have things like oil exploration, other kinds of mineral exploration, where you're going to put a team out in the field, set up what can often be a fairly sophisticated data gathering operation that is in existence for a few days up to a few months, then tear it down, move it to the next place. Once again, those tend to be in vans, but they are well designed, well used, and the key there is having hardware that is robust, because these are typically going into very dirty, nasty, difficult situations, and being able to replace those suckers when they inevitably go south is critical.
Chibert, same question to you that I gave to Glenn during the interview, and that is, we've seen a subset of RDN, the event networks, really change over the last couple of years. I remember when we would roll into Interop with literally 20 different knock pads, knock racks that we would need for all the services, all the different servers that we ran. And slowly that started to shrink as we went into virtualized servers and as we started to move things into the cloud. This is a trend that we're going to continue to see in those types of networks, right? You just get me a connection to the outside world, I'll give you a couple of switches, and we're ready to go.
Yes and no. It all depends. Like for emergency services, you don't always have large amounts of pipe. You might only have a cellular data network, so that means you need to shift more of the services locally. In fact, one of the projects that I did long ago was actually setting up a new network, a greenfield install in Alinganai Atoll in Polynesia. And basically the only link the entire island nation had was a pair of T1s over a University of Hawaii satellite. So with that, we started doing a lot of caching. So it all depends on your wide area network connection. Some people will bring a lot of stuff close to them so that they have access to it and then just synchronize over the small WAN pipe. But in the case of Interop, since we have such ginormous pipes, it makes a lot of sense to push a lot of things into the co-location facilities that CenturyLink gives us. And that gives us the ability to work on them year round and have more time to work on, some of the emerging infrastructure like 100 gig.
Speaking of ginormous pipes that are pushing a lot of things, we've got a topic up next that we're going to do a deep dive on: software-defined network. Now, I know what you're saying. You're saying, wait, Padre, we've covered SDN before. That's true, but this time we're going deep. We're going really, really deep. But before that, I want to take some time to talk about our last sponsor. Oh, I'm sorry, not last sponsor, but second sponsor, and that is Ting. Now, you may be asking yourself, what is Ting? Ting is a no BS cell phone provider. They're an MNVO, a mobile virtual network operator, essentially meaning that they resell Sprint service. So the same Sprint network that you know and you love, that you know is going to be there, that's going to be reliable, that's right, that's what runs Ting. Now, how is Ting different? They're different because they have no contracts. They have no early termination fees. They are truly and completely contract-free. They don't bundle or add ride-along services. You get to choose from extra small to extra large service levels for your voice, your minutes, your text messages, your megabytes of data, all billed separately so you understand what you're spending your money on. There are no overages or penalties. If you use more than you thought you would, you just pay for what you used. If you use less than you thought you would, Ting drops you down to the next level that you hit. I like to see one of the big telcos try that. They also have no add-on charges: voicemail, caller ID, tethering, hotspot, three-way calling, call forwarding, and all the other features that you should have as part of your service actually are part of your service. No add-on charges. There are no mysterious line items that show up on your bill. Ting charges you for what you use plus whatever taxes they're legally required to collect. No hidden charges, recovery fees, or other BS line items. They offer you unlimited devices on a single plan. You can share your pooled minutes, messages, and megabytes. Each device on a plan just costs you an extra $6 flat per month. A powerful online control panel is also included with your subscription. You take control of your account, your usage, your bills in a powerful online control panel, and you get no holds barred customer support. Call them at any time, 1-855-TING-FTW, anytime between 8 a.m. and 8 p.m. Eastern Standard Time, and a real person will pick up the phone. If you don't like talking to real people because maybe like me, you're antisocial, they also have excellent online support. Go to help.ting.com and you can see an active customer forum, a simple and powerful help ticketing system, video tutorials, video startup guides, and much, much more. So here's how Ting works. You purchase your mobile device from Ting, which you will receive in 2 to 5 business days. Then you activate your device with Ting and have the option to select a new phone number or port an existing one. Ting will break your rates out by minutes, text messages, and megabytes, and bill you at the end of the month for what you've used. So here's what I want you to do. Visit Ting today at enterprise.ting.com. That's enterprise.ting.com. You can save money and better manage your mobile phone usage with Ting. Check out their savings calculator and see how much you or your company can save by switching to Ting. This Week in Enterprise Tech viewers also save $25 on their first Ting device when you sign up. So visit enterprise.ting.com today and start saving now. And we thank Ting for their support of This Week in Enterprise Tech. Let's get into the meat of things. We're talking all about software-defined networks with TailF. Now, we've got a special guest here, Mr. Carl Moberg, the VP of Technology from TailF. Carl, VP of Technology, like all technology. What exactly does that mean?
Well, I recently moved from Sweden, where we have much more, low-key titles to the Valley, right? So we had to assemble a group of Swedish people to come up with a Valley title. So yeah, VP scares people, and technology is fluffy enough that they will take my calls. So the combination turns out to be killer.
Okay, well, so what we want to do, though, since you're now living in the United States with our IT system, you need to have a really long title, like VP of Directly Vertically Integrated Software-Defined Networking underneath Dell servers. Yes?
For sure, and I can see that the IRC guys are already on the case.
Yes.
So I'm just going to pick one.
Oh, Viver Mike, you are now the VP Ninja. VP, I do kind of like that. All right, let's get into it. All kidding aside, we've heard about SDN. We've actually had guests come onto the show and talk about SDN, but one of the complaints that we've received from our viewership is that it was a bit too ivory tower. They wanted us to get into it. So let's start with you. The general question that everyone gets: what is SDN? In your mind, what is a software-defined network?
You know, it's one of these things that really lands strangely in our beloved infrastructure industry, right? It started out with a particular meaning. It was quite attached to what was known as the Clean Slate project at Stanford and pretty directly tied to the OpenFlow protocol. But as that kind of was released onto the wild, and the wild meaning both the people that are going to try and use it in the real networks today and the vendor base, actually the definition has kind of been stretched. And I think, you know, the last remaining kind of middle ground here is based on the expectations that I see people attaching to it, which has a lot to do with, let's call it programmatic access or automation, right? Just a way of using programmatic means to influence the network and its configuration. And it's kind of transcends technologies these days. You know, there are many ways to draw an SDN, so to speak, but I think it comes down to that thing, a comfortable environment for software, applications, and actually to some extent for humans to manage your network assets as if it was one coherent beast, right? So that's what it's kind of converging to.
All right, all right. Now, TailF, I know TailF because you actually support interop. We went out and we decided that we needed to have a big SDN component to our network, and so we started shopping around, and TailF offered us one of the most innovative solutions. So my question to you is, exactly how is TailF involved in SDN? What is it that you do?
Oh, it's a great question. So the background of the company is actually that we spent the first couple of years in helping equipment providers build better software for their routers and switches and whatever they're building in terms of manageability, right? Configuration, programmatic APIs. And we kind of realized in the 2010 timeframe that there's going to be an opening for a centralized piece of software that will again expose the network as a manageable asset, something that programmers are comfortable talking to, and something that network engineers are comfortable, again, addressing as something coherent, right? So what we did is that we brought up this software called NCS based on our experience with building that type of software for the network vendors, right? So it was kind of built to actually work on real existing networks, and I'm only half joking when I say that one of the great things about it is that it exists and it can work on your network right now. And so what we got the opportunity to do with the interop network, which was great, right? We've always been looking for the most obscene, if you like, the most complicated networks in the world to see if we can really hold up to it. And you guys are building a very complicated network. It's got a lot of moving parts, it's got a lot of vendors, a lot of products, a lot of versions of software. So we managed to bring this stuff up actually on top of that network. I think it's about 17 different products from, I believe, 7 vendors. And again, expose all these configurables, all that good stuff that's going on in the network through a set of northbound APIs ranging from REST and NetConf to Web UI to actually a Cisco style and Juniper style CLI. So what it hopefully does for the interop team is that it gives it, again, a coherent way, and hopefully I actually think it's going to really, really tie into that rapid deployment network idea, because you get a single point of entry and you get a single point of, if you like, storage for all the configuration and services. So you can actually mix and match vendors, and you can rip out equipment and replace equipment and don't care so much about the minute details of all the protocols and all the technologies, right? So that's what we've been doing, sitting on top of the interop network, managing it and providing a coherent northbound interface that would allow both humans but also applications to address it, to change it, if you like.
Right. Now, Carl, you've got fans here. Chibert, Curtis, and I are all fans of SDN. We believe in the promise of SDN, but a lot of that can, let's be honest, can sound like buzzwords. We get what SDN is supposed to do. It's supposed to sit on top of the infrastructure and allow us to rapidly deploy things, to move configurations from set to set. But let me get you into the nitty-gritty. Let me hold you to these details. How do your customers actually use your software? How do they deploy SDN as customers of TailF?
Again, and here's what's cool, right? We actually have one. It actually can be introduced in your network, right? So we quickly get the opportunity to start talking to operational teams about what their concerns and worries are. And literally what we're looking for is kind of things that are moving, or where the frequencies of change in the network are high enough that humans can't keep up or don't want to keep up. When the complexity of each change is such that, you know, you actually have to be like a living lexicon to understand it, and where it's very expensive to fail. So that's kind of what we're looking for, right? When we talk to, well, everything from service providers to some of these massive data centers, right? And there's a couple of ways, or a couple of things that always comes up. There's things like VPN provisioning. Most engineers that I know really would be much better off if they were never had to provision another VPN. Just not only because it's repetitive and quite tedious, right? But also because they fat finger stuff and do things. Probably not what happened to Amazon today, but certainly has wreaked some havoc before. And the second thing is things like firewall management. Another thing that's just explosively complex and very, very boring to do. So we kind of home in on these things that people, again, where humans don't scale, if you like. And it is things like VPNs, it is things like firewall management, and there's one thing called service chaining that keeps coming up, all ranging from mobile backhaul networks to new data centers. So just ways where people want to get out of the loop, not because they don't think they can do it, because it's too slow and they're too error prone.
Yeah. Chibert, let me go over to you. We've talked about SDN before, and a few of the things that Carl mentions are fantastic. I mean, easy deployment of VPNs, easy deployment of security policy, easy deployment, for me, of VLANs would be fantastic. I'd love a tool that I could take all the VLANs I know I'm going to need and then drop them onto an open architecture to get back the services that I want up as soon as possible. But how does this strike to you? I mean, listening to Carl talk about how his customers are using TailF, listening to Carl talk about how his customers are deploying their own software-defined networks, does this match your experience of playing around with things like OpenFlow and virtualized services that can be turned on at a moment's notice?
Let's talk about the promise. The promise is that we want to be able to go and make changes rapidly, easily. We want to be able to reduce my cost of running this large complex network. And we do that by making things easier to do, less management tools to deal with, less panes of glass to go and find data on. However, one thing that my cautionary tale on this one is change management. That's one of the things that I haven't heard a lot about in the software-defined networking world. I'm sure it's there, but there needs to be some checks and balances. When you have a single tool that can make some very sweeping changes, without change management, we could very easily make a change that could cause something like Amazon to happen. Let's make sure we cover that before we start putting the kingdom under one set of keys.
Got it. Curtis, over to you. From the executive level side, when we talk about SDN, one of the things that really catches their attention is it could have a really high ROI. It could also have a fantastically low cost in moving operations or in getting backup operations. Do you think that is a much bigger focus once you get past the tech, the fact that I can bring my network up in redundant areas, or that I can deploy services without having to have huge teams on site moving in forklift hardware upgrades?
The key word for a lot of executives these days is agility. They love the idea that they can readily change a configuration to meet shifting business needs. That's one of the things that has made virtualization a huge win. It's one of the things that's used to sell cloud. The idea of software-defined networks, of virtual storage, of virtual everything, ultimately comes down to two issues. One is full utilization of hardware. The other is ease in redeployment when things change. That's the thing that really gets people excited at the executive level about software-defined networking. The notion that as their business needs change, they can alter their network infrastructure to match the conditions without having to go out and spend a huge amount of money on those capital expenses we talked about a segment or two ago. Simply making some operational changes and you have a whole new network. That's a really, really attractive proposition for the average executive.
Yeah. Carl, I know you have access to the TailF tool, so I think I'm going to spring something on you. Listening to Chibert and to Curtis talk about the things they like about SDN, I want you to actually show us something. And I want you to show the thing that I am most peeved about, and that is having to transfer over VLAN configurations. Because it always seems as if whenever I'm trying to set up VLANs, that's when I fat finger things. And that's when I spend hours and hours figuring out that one switch that I've misconfigured that is messing up my entire network. Show me how SDN can help me deploy VLANs properly from one network to another.
I will be glad to do that. And you know what? I just want to, since I'm Swedish, right? I want to say, I'll show you how one take of SDN will address that, and I'll show you our take on that. So let me see if we can get the demo, I guess, up and running here. Should I just go ahead?
Oh, absolutely, yeah.
Okay, cool.
Oh, no, our technical director, Jason, he is on it. He'll be switching back and forth. You just do your thing, he'll do his.
That sounds great. Okay, so there's a web UI. Here's a web UI. And I'm going to log into our web UI. So what I have here is a newly started NCS. So NCS is the name of our SDN controller, right? So this demo actually shows Q&Q VLAN provisioning using traditional means, if you like. We actually use the Cisco CLI and a little bit of the netconf protocol, addressing two different types of devices, Cisco's and actually switches from PK8 in this simulated environment. And the first thing that will happen in a demo like this, and I'll show you that we have now, since we have just started NCS, right, our local database, the database that will eventually consist of all the configuration that we care about from all these devices, are right now empty. But we have a pre-populated list of devices, so we have the kind of the reachability information in terms of IP address and port. And we also have what we call a NED type, or network equipment driver type. So we know that this is a CLI of type Cisco, and we know that these guys are netconf. So the first thing we'll do in a system like this, obviously, is to synchronize from the network, right? We'll read the configuration, we'll reach out using whatever means we have here, so Cisco CLI and netconf, and read the configuration from these devices into our local data store. Now, this is a web UI, right? So all the exciting stuff happens behind a spinner, but the demo gods seems to be, oh, I need to do it for all. Actually, I can't just put focus on one of them. Sync from devices. Let me do this. So I just synced one of them now.
The wonders of the live demo.
Exactly. See? You guys in the back, can you see my pulse going up? I have all types of things here on me. Okay, sync from all devices. Again, all the cool things happen behind a spinner. That worked out fine. Okay, so what I've done now is that I've actually used all these, or these two types of protocols, right? The Cisco CLI and netconf, to fetch the configuration data from these devices into my local data store.
So you've just pulled all the configs?
I just pulled all the configs.
Okay.
So for the hardcore people in the audience, what I'll show you now is that I'll start a Juniper-style CLI towards this system, right? So what you have here is actually a Juniper-style CLI managing the whole network. Since I have the configuration in this system, I can enter configure mode, and I can start setting configurations to, let's say, a range of devices. So I'm going to now change the configuration of all devices between C0 and 2, and their config. Of course, all good demos always change the community of the SNMP server. So I'm going to do that. Let me actually use a better word. Like that. So what I've done now is that I've changed the configuration of the network as it's represented in my local database, right? Mm-hmm. So I can show you that the outstanding changes that we have towards the network from a system point of view is now in 3 places. I'm not going to bore you with the details, but here's a diff output, right? And the cool thing, of course, here is that you can make arbitrarily complex. This is a centralized system, right? So you can do arbitrarily complex changes to this network from this single CLI. And believe me, we can do this from the REST interface. I could have done it through the web UI. I can do it from netconf. And then I just go ahead and commit it to the network, right? So this actually takes care of all the tedious parts of committing this and making sure that if something fails, let's say something fails in box number 2, we will roll back to the point in time that we were before. Okay? So this is still, you know, one could argue that we're still on the kind of device layer. So where's the software-defined network, right? This seems to be just a powerful CLI. So if I hop back into the web UI and I'll show you the Q&Q application that you so much, you know, want here. This is my tiny little demo network. It's got PICA switches, got Cisco switches, and I've made myself a service. And this service is actually a combination of a standard modeling language and a little bit of code. So in order for you, Robert, to create this, what you would do is that you would click the create button. You have to name it something, right? And just in the spirit of being Swedish, right? I'll name it, Volvo. That's the one that's going to survive. And I'll add an SVLAN, right? So this is actually, you know, pretty boring, but it is a Q&Q VLAN. But I'll just, like any old chef, I'll go ahead and populate it with some more meat here, so we have something to play with. So just adding some edge switches from the network for this particularly complicated Q&Q VLAN, and we add some core switches. All these things, of course, is pulled from the network. There's nothing hard-coded here because we have control of the whole configuration. So now we have a more interesting Q&Q VLAN, okay? Number of edge switches, number of core switches, and again, all we have to do here, and before I show you that actually, all this system does is that it takes this high-level representation of a Q&Q VLAN and actually translates that into native protocol, if you like. So this is actually a pretty interesting mix of Cisco's CLI commands and actually netconf RPCs, right? So independent of which protocol you're using to talk to this box, and we talk a lot of protocols, including REST and including OpenFlow and the emerging I2RS protocol. Actually, the protocols you talk to the boxes is not important. It's what you do on top. It's the abstraction and how comfortable this is to use.
So this is doing a test deployment to a virtual network. You're essentially taking all the configs that you pulled off and trying them out, and it's going to simulate the network?
It's going to simulate the network in the sense that we will send, by clicking this green save button, I'm now going to commit that change to the network, right? So now the network actually has a service running on it, right? So we have a list of services down here. Let me bring it up so you'll see it. So this configuration is now actually live in my little simulated network that I have here. And of course, this can be done with a very ambitious set of templates, perhaps, but here's what you can't do. And this, Robert, I think is where you will really like this. We can actually change something profound, like the SVLAN of a Q&Q network, and we'll just do the same thing again. We'll just native commit try run this, right? And it will compute all the very complicated changes you have to do across all these vendors.
Yes,
without you having to touch that. And you can make it arbitrarily complex. Let me also just remove a switch in the same round of changes here and do the same thing. And it would just compute the ordered set of commands that we'll send to the network. So it really, again, takes away all the minute details of talking to the network, and it allows people to use more of a natural and comfortable environment, which is this service layer here. And of course, I can commit it, and just for last wow factor here, so I committed that change to the service. I can, of course, also do a rollback. We talked about rollbacks. We talked about change management. I can literally roll that service-oriented change into the system, which was about changing the SVLAN and removing a switch. I'll just load that, and I'll save it, and we're back to where we were before. And this is the type of abstraction that we find that most people, including the most hardcore cynical network engineers of the world today, because believe you me, when I go into the room to demo this thing, they lean back. They give me 15 minutes. They've seen this before. But again, with things like transactions and transparency around what we're doing, the conversations quickly turn into what they want to do with this software here. So it's a pretty interesting proposition.
As a throw over to our chat room and to our audience, I know that if you're not a hardcore command line using network geek, this can be a little difficult, but this is excellent. This is a deep dive on a tool that could save you not hours, but days, weeks of configuration when you're bringing up a new network. Essentially, what Carl just showed us was the ability to go to your working network, pull off your VLAN structure, make the changes that you would have to, the subtle changes, the modifications that you're going to make when you bring up the new network, and then throw it onto that network after having tested it inside their network emulator. That's unheard of. Cheebert, let me throw over to you. A tool like this, where would you use this on, say, a university campus?
I would use it anywhere. In fact, Carl, I want a copy. In fact, Carl, I want to do an InfoWorld article on this. This is very sexy.
Right. Now, let's go over to you, Curtis, because he talked about being in rooms of executives and executives even getting this. Do you understand what's going on here? And do you understand the power that this tool has if you actually have the ability to not just pull your configs, not just emulate a network, but throw it up onto a freestanding set of new gear and be up and running in a matter of minutes? That actually changes how we look at IT, right?
Oh, it does. It means that rather than having to have an army of people who are able to go in and do command line configurations, you can have a small team of people who can do that, who can then replicate it as many times as needed. I really do hate to, at this part of the evolution of the industry and our economy, talk about being able to make do with fewer experienced and trained individuals. But the fact is, it does lower costs. And what I'll say is that I think that something like this could allow those experienced, very highly qualified individuals to be redeployed to much more creative and potentially profitable areas of the company, while still allowing a handful of people to make network configurations apply across wide swaths of the infrastructure, and especially when it comes to remote offices, to branch offices, to regional offices, things like that, where you can just essentially hit cut and paste. That's a huge win for the enterprise.
Now, ladies and gentlemen, you've done it again. You've used up another hour listening to the best dang enterprise tech show in the universe. That's right. I actually spoke to the universe, and it agrees. But you know what? We're not done yet. When we come back, we're going to say goodbye to our panel. We're going to say goodbye to our guest expert. We're going to get final, let's say thoughts on SDN. But before we do that, I want to welcome a brand spanking new sponsor to the Twilight Riot. Now, we've talked here on Twilight about the end of the PC era, and most of the time we make fun of it, but there is no doubting that we're definitely making a move from PCs and laptops to more mobile devices. And so if we're doing that, we need to look at security in a different way. It's not the same old desktop and PC era. It's a brand new world, and you got to embrace it. And that's why I'm happy to welcome Lookout to the Twilight Riot. Now, Lookout is a mobile service company, security company based out of San Francisco, and they're mastering this new approach of security for mobile devices, securing the next generation of connected devices for 40 million people globally. The Lookout platform is built on the world's largest mobile threat analysis system and uses it to protect against malware, spyware, privacy issues, and phishing, among other cybersecurity threats. So it's not just an antivirus, it's a complete security package. Now, here's what you get. Lookout for Android, iOS, and Amazon Kindle offers you the best protection for your personal devices with such features as automatic protection from malware, adware, and spyware, a premier Find My Device solution, one of my personal favorites, Signal Flare, which is a feature that lets you automatically save your device's last known location when your battery gets low to significantly improve your chances of finding it even after it runs out of juice. You get automatic data backup and restore, and easy device management from Lookout.com. Anywhere, anytime. Lookout worries about security so you don't have to. They've stopped tens of millions of mobile threats to date, and they have a product for business coming soon. So here's what I want you to do. If you use a mobile device, if you're part of the mobile generation, you owe it to yourself to learn more about Lookout for business, or get the free Lookout download for Android, iOS, and Amazon Kindle. You can visit lookout.com/enterprise. That's lookout.com/enterprise and get all of your goodness on your device. That's lookout.com/enterprise, and we thank Lookout for their support of This Week in Enterprise Tech. I want to thank all my panelists for an actually excellent show. We talked about everything from TAPS to security to SDN, rapid deployment networks. They were right in the mix. Let's start with you, Chibert. What's going on with the nerd in paradise, the geek in the volcano? Well, what's going on in Hawaii?
I'm trying to convince Carl to hook me up so I can do an InfoWorld article on this.
Okay, so we can expect that. That's coming soon. InfoWorld Chibert deep dive on TailF.
You bet. In fact, I'm going to be reviewing a couple of software-defined switches, so I think we could have a whole lot of fun with this.
I indeed believe so. Curtis, over to you. What's going on with enterprise efficiency? I know you're always on the road, but you also have your own absolutely fantastic program for a hardcore enterprise guys. Tell us a little bit about it.
We do. One of the things I do is E2 Radio, and we actually have 2 great episodes this week. The one tomorrow is one that I think that the Twilight Riot would love to be at. I'm going to be talking to a gentleman, Mr. Myron Weber, about data and how companies get it wrong so often and what they can do to get it right. 2 p.m. Eastern Time tomorrow, E2 Radio. Come on over to Enterprise Efficiency. Join us. Would love to have the voice of the Quiet Riot in that radio audience. On Friday, I'm doing another one, the Mindful CIO, looking at mindful techniques. That's at 11 a.m. We've got more shows next week. It's a great thing. You know, it's different than the Quiet Riot. I love this. But it's great when some of the people here can come over and be with us there. It's the two great audiences, and I love being able to talk to both of them.
And over to you, Carl Moberg, the VP Ninja, I believe is the title that we've now given to you.
That one won out. I think it lost in length, but certainly in brevity.
Absolutely.
Yeah.
Thank you for this demonstration. I mean, we really needed something to bring SDN down to earth. We wanted to back away from the 10,000-foot view, and I think you absolutely did it. Tell us, how do we find out more about TailF? How do we find out more about the work that you're doing? How do we find out more about what you're doing at Interrupt?
So I think, first of all, take a look at tail-f.com. Tail-f.com, we got a lot of information there. Reach out to me at cmoberg on Twitter. Come to Interrupt and take a look. I mean, one of the things that is really striking with this type of solution, again, I'm only half joking when I say that the cool thing is that it exists, is to see it in action. Because it can be a little bit hard to explain it, especially to a camera like this. But certainly, come look at a demo. And we'll make sure that you guys will have your heads blown clean off.
Thank you. Thank you to all my panelists. But you know who else I want to thank? I want to thank you. And you know how we're going to do that? We're going to do that by letting you download automatically every episode of Twiat Goodness to your device of choice. That's right. If you go to our show page at twit.tv/Twiat, you'll find a drop-down menu with all the different ways that you can get Twiat downloaded into your device of choice. You want it on your iPhone? No brainer. iPad? Duh. Android phone, Android tablet, your Zune, your laptop. We give it to you because we know that you need to get the knowledge about the network goodness. Also, did you know that we have a YouTube page? If you go to youtube.com/Twiat, not only will you be able to watch all episodes of Twiat, but you'll also be able to get our individual segments. Was there an interview you particularly liked? A data closet, stuff my IT guy says. It's all up there, ready for you to find out what you need to know about the network world around you. Also, you can follow me on Twitter. In fact, I'd love for you to follow me on Twitter at twitter.com/PadreSJ. There you'll be able to find out what we're doing each week, and you'll be able to either ask questions about old shows or suggest topics about future episodes of This Week in Enterprise Tech. Also, did you know that we actually do this show live? That's right. Right now we're live. So if you're not watching this on a downloaded link, this is actually happening. This is the real world. We're double rainbow complete in here, and we want you to join us every Monday at noon Pacific time. Go to live.twit.tv, and you'll be able to see how the sauce is made. You get to see the pre-show and the post-show, all those good things that make Twit such an interesting experience. And as long as you're watching live, jump into our chat room at irc.twit.tv. There you'll be able to speak to some of the brightest engineers, some of the funniest people, and yes, some of the coolest trolls you'll meet in the interwebs. Finally, I want to thank everyone here who makes this show possible, to Carsten, my super producer, to Leo, Lisa, everyone who supports the show, and also to, who's over there? That's right, that guy.
Hey.
Jason Howell, my technical director.
And me.
Infinite Jason. Now, Jason, I heard from a little birdie that you do a show about Android. Is it like about everything in Android? All things?
It's all about the things that are Android.
That's a catchy title.
Yeah, I think I'm going to shorten it, though, to All About Android. And it'll be twit.tv/AAA, so that you don't have to think about anything more complex than that.
Absolutely. Thanks to everyone, and especially to you. I'm Father Robert Ballister, reminding you that if you want to know what's going on in the Enterprise, just keep Twiat. So if you're buying anything from Amazon and you're not using the tool...
Whoa.
Hold on. That's why we have safety wire.
Thank God for the safety wire.
No kidding.
Wow.
You almost dropped those two guys in their head.
That was impressive.
Cheebert, Curtis, are you guys okay?
How many G's did you take on that drop?
Man. If we ever wondered why we go through the extra steps
Of the safety wire? That's why. We got a lot of equipment hanging overhead.
Because those safety things, you're like, yeah, but nothing ever
like
happens. Like, why do we?
I feel like
That's
making
why.
out with blue shirt guy there.
Did this have anything to do with the fact that earlier today Burke was asking me for some extra screws?
Not related.
Did Burke say he has some screws loose?
No. I see what you did there.
Whoa,
Watch the hands back there. Watch the hands.